AOC 2022, day 9. You can see from here, it looks like we're walking along the path here, and we come to, right, there was a jungle, the trees from yesterday. And I'm not sure what these are, but we'll find out. Day 9, rope bridge. Oh, maybe that's a bridge. This rope bridge creaks as you walk along it. You aren't sure of how old it is or whether it can even support your weight. It seems to support elves just fine, though. The bridge spans a gorge which was carved out by the massive river far below you. I guess we're not an elf. We're just a human. You step carefully as you do. The ropes stretch and twist. You decide to distract yourself by modeling rope physics. Okay, maybe you can even figure out where not to step. Consider a rope with a knot at each end. These knots mark the head and tail of a rope. If the head moves far enough away from the tail is pulled towards the head. Make sense? Due to nebulous reasoning involving plank lengths. Okay. You should be able to model the positions of the knots on a two-dimensional grid. Then by following a hypothetical series of motions, which is your puzzle input, for the head you can determine how the tail will move. Due to the aforementioned plank lengths, the rope must be quite short. In fact, the head and tail must always be touching. Diagonally adjacent and even overlapping both count as touching. Okay. If the head is ever 2 steps directly up, down, left, or right from the tail must also move 1 step in that direction so it remains close enough. Okay. 2 steps directly up, down, left, or right. Right, okay, so it's just showing here, if the head moves 1 to the right, then the tail is now 2 steps away, so it needs to move directly that way. Otherwise, if the tail and head aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. Okay. So the head and tail are diagonally separate. The head moves up by 1. That means the tail has to move diagonally in that same direction. Okay. You just need to work out where the tail goes as the head follows a series of motions. Assume the head and the tail both start in the same position, overlapping. And then we have some test input. This seems complicated enough that I'm going to use the test input like we did yesterday. The series of motion moves the head right 4 steps, and up 4 steps, and left 3 steps. Yeah, down 1, right 4. I get it. I get it. Visually, these motions occur as follows. S marks the starting position as a reference point. Okay. All right, so we have head, tail start, head, tail, start. Okay. And then this is the diagonal movement they were talking about. So you go up 1 and the tail has to basically takes the place of the previous head's position. So we can just kind of do it that way. And okay, wow, this is long. After simulating the rope, you can count up all the positions the tail visited at least once. All right, so that's the question here. How many positions does the tail of the rope visited at least once? And it makes this kind of funky little pattern. So what we can do, we can use the test input. Let's use the test input. We'll get the regular input, which is probably going to be a little bit longer. Get input 2022 day 9. It's 2,000 lines. We're going to write into test input just to have this. Are these all like 1s and 2s? They don't go any further? Let's take a look. I'm just curious about how the input looks here. Well, they're all single digits. Sort dash n plus 1, this tail. No. They go up higher than 18, 19. Okay. Interesting. All right. We have our test input. We have our real input. Let's create the file. Oops. 9 day 9. Okay. (22:09). That's the last time we're going to have to delete a leading 0. And let's get bacon running. Oh, yep. I already set it up for today. There we go. Okay, beautiful. So I think the input parsing should be straightforward. What we can do is we can create an enum of a direction of up, down, left, right, and that'll allow us to convert the up, down, left, right into a number. Impl direction fn parse s stir self match s. Up is going to be self up, and so on and so on. Down, left, right. Down, down, left, left, right, right, and then panic invalid direction S. Right? Just basic stuff, just to get that going. We should get a warning that we're not using it. Correct. And now, what are we going to store here is basically just all the steps. So we'll call them steps, which is a vec of direction. No, it's a vec of direction and amount. Let's make everything I32s just for simplicity. And so parsing should be we can say for line in AOC lib read lines of, and we're going to read the test input. So that we can compare our disaster with the actual movement here. Right, and we'll print these out. We have a little 5x5. It looks like it's all, or maybe it's a 6x5. Well, that'd be fine. So, yeah, and if up is, should we call up negative and down positive? Yeah, we can do that. As long as we're consistent, it's all good. So let command is equal to, actually we can say that let dir dist equals line dot split once on space, and then let dir is equal to direction parse dir, and let dist is equal to dist dot parse unwrap, and we can say self steps dot push dir dist. And then for part one, let's just print out, I think it was 2000. Oh, for the test input is only a few. It's only 8. So we should see 8 for the test input. Self steps len. And what do we get? We get a panic. Nice. Invalid direction R. Oops. Oh, right. This is U, D, L, and R. 8. Perfect. All right, so now we have all the directions. What we can do now is let's create a snake. Struct snake. And it has a head and a tail. And I'm doing everything with the I32s just to keep it nice and simple. I guess we could just do one move at a time with the snake. And in part one, we can just send the commands one at a time. And that way the snake just has to take care of the head and tail. It doesn't have to worry about making multiple moves. We can say impl snake derive default, so we don't have to create a new function. Let's create the directions. And we have to do it in the same order here because I'm going to convert this into 0, 1, 2, and 3. So this is going to be a vector of I32, not a vector, a slice. A 4-way slice of, so up is -1, down is 1, left is -1, and right is 1. Right, and then we can just say impl make, no, fn make move. I can't just call it move because move is a keyword. Self, and then we need a direction to move in. And it doesn't return anything. All right. So yeah, we have a bunch of dead code. That's fine. I just want to make sure it compiled. For part 1, it's basically for step in self steps for nothing in 0 dot dot. Oh, we can just say amount, right? Direction and amount. Yeah. Really? Why is that unknown? There we go. Okay. We can just say let mutt snake is equal to snake default. That way they start at 0, 0. Oh, the other thing I need to keep track of is where the tail was, right? That's the question, is how many locations did the tail visit? At least once. Okay, so let's add that. Used collections hash set. And we can throw that in here. Visited is a hash set of other2. And then every time we move the tail, we can just insert it into there. And that will make this snake.visited.len as our answer. Right? So as we move the head, the tail gets moved, and then as we move the tail, we insert it into visited. The hash set will keep track of whether or not we've already visited that location, and we don't have to worry about multiple visits to the same location. So then the length of that visited hash set will be the number of places the tail of the rope visited at least once. All right. So all we need to do is now say snake make move dir for each for in 0 dot dot amount. Probably could use function composition here instead of this, but this should do the trick. Amount is a reference. All right, so I think we're almost there. Now we just have to do the hard part. All right, yeah, so the framework is in place. We can read all the moves from a file and parse them. And we can call make move in the correct direction, I assume. We can actually print that out, right? Let me put a drive debug on here. And we can debug out each step as we make them, right? We can just say dir. And then we can see those here. And make sure that we're actually doing it. So we're doing 4 rights, 4 ups, 3 lefts. And I think that's correct. Let's go to the top. 4 rights, 4 ups, 3 lefts, 1 down, and then 4 rights. Yeah. Okay. So I think we're correctly parsing, and we're correctly calling make move. And now we have to do the hard part of actually doing the move. So what were the rules? The rules were, if we're 2 steps directly up, down, left, or right from the tail must move 1 step in that direction. Okay, so the first thing we need to do is move the head. Before we do anything, we move the head. Self, head. Oh, let's get the direction. Let dir is equal to self dir of dir as usize. And then we can print that out. Let's maybe we call it something else. Delta. And then we can say delta. Right. So now we should see the deltas. Oh, right. Have to deref that. Still not good. Because dir has, okay. Yeah, so now it's picking the correct direction. Right is that way, up is that way, left is that way, and down is that way. Perfect. Okay, so now we just modify the head. Self head 0 plus equals delta of 0. Self head 1 plus equals delta of 1. And now we got to say if the tail is more than 1 step in a direction up, down, left, or right, then we have to move the tail in that direction. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail always moves up one step diagonally to keep up. What's a good way to do that? We got to check 2 steps here. So if one of them is 0, right? If the difference is, so okay, we have to get the let row diff is equal to self tail. Which way do we want to do this? Right? We want to subtract so that row diff ends up being negative if we have to move to the left, and row diff ends up being negative if we need to move up, and positive if we need to move down. So that means if I say tail 0 minus self head 0, that means it'll be that, right? Because if tail is bigger than head, we want, oh no, the other way around, right? Self head 0 minus self tail 0. If head is bigger than tail, that means it's further to the further down, right? Positive. It's further down, so we want to have this to be positive. Okay, I think that's right. Let call diff is equal to self head 1 minus self tail 1. Right, and now it says if we're ever 2 steps up, down, left, or right, then we move 1 step in that direction. So if row diff is 0 and call diff dot abs is greater than 2, then we want to move the tail in the direction. So it would be self tail. Oh, yeah. So call diff. So we want to move left or right, which is dot 1 plus equals call diff signum, right? And signum will convert it from a positive to positive number to 1, a 0 to 0, and any negative number is negative 1. So that should give us the correct move here, as long as we're greater than 1. It's got to be greater than 1, right? 2 steps. It shouldn't ever grow more than 2, but we'll just say greater than 1. Else, if call diff is 0 and row diff dot abs is greater than 1, then self tail dot 0 plus equals row diff signum. Else if row diff is not equal to 0 and call diff is not equal to 0, that means we have to move diagonally. So how are we going to move diagonal? We have to move. We have to update both head. Both tail.0 and tail.1 in the correct direction. So I think we just combine the two, right? So this probably could be simplified somehow. We don't want to move it if it's equal to 1, right? Because if the head moves up here, then we don't want to move tail at all. All right. So if it's, okay, so that's, oops, abs is greater than 1 and call diff abs is greater than 1. Right? Is that, yeah. So if the head is here and the head moves up 1, then the absolute difference between them is still 1, so the tail does not move. And then when the head moves again, then we move tail in this direction of head, so it should end up being in the same like this. And we'll test it out here. It looks like we have the full output, so we can do a step by step. We also want to set visited. Self visited insert self tail. Clone. Do we have to clone it? Can we do this? Let's see what happens. Yeah, we can do that. Okay. So now I'll say for row in -5 to 5, for col in -5 to 5, if self visited. Oh, I want to print out the head and the tail. If row col is equal to self head, print bang h, else if row col is equal to self tail, print bang t, else if self visited contains row col, print bang hash. Else print bang dot. That means there's nothing there, and then println like that, and then we're going to print out just a line in between each move. All right, let's see what happens. So I'm just following here. We have, I guess I skipped the first one, the initial state. I didn't print it out, but we do have TH, which is this state here. And we have TH with our starting position. We have TH here. We have TH here. This is going to be a little awkward to do because I have to do this. All right, and then we're going to go up. So then we have the HT here. Whoops, okay, so we have a problem here where the head moved and the tail did not. Okay, so that's our first bug. The tail should have moved right up to here and it didn't. Let's find out why. And it must be this check here, right? Oh, greater than, they both have to be greater than 1. Oh, okay. If they're both greater than 0, let's see if that does it. Right now, so that was just a hack, right? I'm just hacking now, just trying different things instead of actually doing it. Blue Smoke says, I need to check the docs on Signum. Yeah, Signum just returns -1 if you have a negative number, 0 if it's a 0, and +1 if it's a positive number. All right. We lost T here. But now, okay, I think it worked, right? We have 4 spaces, right? And then HT. Yeah, this might be doing the trick. And then let's see, does it print out? It prints out 16, saying we visited 16 locations. What is it supposed to be? It's supposed to be 13. Okay. So we're not quite there. I bet it's a diagonal thing. Although this looks correct. It actually shows what it should look like. And it looks like there's an extra spot here that doesn't belong. Or extra 2 spots that don't belong. So actually, let me run this in here so I can go back and forth easily. So we went up and we went over. Oh yeah, okay, so it must be this bug here, whatever this bug here is preventing the T from showing up. Right, because this is this state here, and then we go over one, and then for some reason T is not there. But then we're here. That's correct. And it is recording the fact that the T was there. All right, so what's the next one? Looks like this. Which is this one here. Then H comes down 1. And again, the T is missing. And it should be like this. And it's, because I think this goes right one. Yeah, this is going right one, and the T is ending up here. Okay, so that's the bug. That's where the bug lies. The T should come here somehow. Wait a minute. So if we go down, we're in this position, we go down one, the T stays in the same spot. We go over one, the T should stay in the same spot. Okay. Right, so that's this here. So I can't do it, I can't kind of cheat this way. I have to actually do it correctly. I have to move, this says I have to move diagonally. And I'm saying or here. We handle the non-diagonal ones here. Okay, I'm going to try this. Again, this is me just hacking at it instead of actually solving it. Well, looks like we got it right. 13 as opposed to the 16s. That was the actual thing we were trying to go for. Why don't we try it with a real input and see if that does the trick? And if I get it wrong, then I'll have to actually fix it for real. 09 dot text, and I'm going to get rid of this print because I don't want to see this in the output. Oops. Cargo run. We got a number, 6090. Oh, okay, that's it. All right, so that was the problem. This would have to be an or instead of an and. If either one of them, if we're moving, and either one of them is more than one away, then we have to move diagonally. Okay, that makes total sense to me. So that was part one. Git status, git add, source, git commit. Oh, I gotta run Clippy. -m 2022 day 9 part 1. All right. Let's find out what part 2 is about. Continue to part 2. The rope snaps. A rope snaps. Suddenly, the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping towards you as you fall through the air. Uh-oh. The ropes are moving too quickly to grab. You only have a few seconds to choose how to arch your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots, you now must simulate a rope consisting of 10 knots. 1 knot is still the head of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it, using the same rules as before. Okay. Now you need to keep track of the positions the new tail visits. In this example, the tail never moves, it only visits one position. However, be careful, more types of motion are possible than before, so you might want to visually compare your simulator rope to the one above. Here's a larger example. All right, so we have a second set of test data. All right. And this presumably has a greater than one position solution. The answer is 36. And it looks like this. Okay. That would be a lot to work on, but we can try at least extending the snake. Right, we could just put this in a loop. Maybe we make the snake have a length. Instead of just a head and a tail, we have it have a vector of snake segments. And then we can say create a new snake with 1 versus create a new snake with, yeah. So we can do that. Let's the old code's checked in, so I don't have to worry about it. So I can just say segments is just a vec of I32, I32. And then the head will be 0 and the length for 10, it'll be, the tail will be 9. So fn new len new size. Oh, self. And we return a self of segments, which contains vec, bang. They all start at 0, 0, I guess, len, semicolon len, and then visited hash set new. Right? And then up here, I can say snake, instead of snake default, I say snake new 2. And it should still give me the 6090 if I do this. I have to just rebuild all of this make move stuff. So we still have the delta. We still grab that. And we're going to still modify the head of the snake, which is going to be self seg 0.0 plus equals delta dot 0 and 1. And then the row diff. Okay, so now this is where we loop for I in 1 dot dot self seg len. And the row diff is going to be self seg I minus 1 dot 0 minus self seg I dot 0. Right, and this is self seg I, and this is I minus 1. Okay, so that's that part. And now we still, oops, the wrong direction. We still do that. We still do that. But we need to update this code here. So instead of self tail 1, this is seg I. Is that all we need to do? And that'll work its way through the snake. I forgot a comma. This has to be seg of I. Oh no, we only want to do the tail. Right. Self of self seg len minus 1. And then it's still 6090 for 2. Let's use the test input, which should just be, oops, test input dot text. It should say 1. Oh, no. Yeah. Sorry. So this should also be this, except we changed the 2 to a 10. Let's see what happens. Let's say 1. It says 1. Let's use test input 2. And it was supposed to be 36. So let's see if it's 36. It's 36. We don't care about the 88. Now let's use the real input. $25.66. Ah, there you go. Okay, that wasn't too bad. It was definitely hard. I think it was harder than yesterday's because it was kind of fiddly to get the logic right. And, you know, the fact that we had to explain it using massive amounts of text and graphics and descriptions. All the rules were here, right? This was it. Implement this rule and implement this rule. Those are the only 2 rules we had to implement. And let me get rid of all the print stuff. And that's it. That's all of it right there. So it's pretty straightforward. Once you figure out all the fiddly bits around the corner cases, the edge cases. Dr. Monk says, awesome, congratulations, thank you. Your solutions are always very clean. I'm really impressed. For so far, they're clean, right? We're going to get, I'm sure, places where I go off the rails. But this is it. Blue Smoke says, great job. Congrats. Thank you. what else can we do? I mean, the only other thing that would clean stuff up is not have to do this twice. I should be able to just say snake new execute, and it would return, yeah, so moving this into the snake code itself. But then we're tightly coupled as opposed to loosely coupled, so I don't know. I mean, it's all good. If I had a separate function maybe on this, which would take a snake of a certain length and execute the steps on it, and then return that. Maybe that would be maybe that would be something to do. Run snake len usize, and then I can just take this, put it here, and then just return. Oh, and then returns usize, and then it's just snake visited len. Right, and then part 2 becomes run snake 10, and part 1 becomes run snake 2. Yeah. Let's see if it's correct. It is not. Oh, self. Wow. Oh, this, duh. Oh, right. And then I have to put this here. Otherwise, we get the same answer every time. There we go. 6090 and 2566. Cod3 Monk says it takes me much longer to come up with code that clean. Well, okay. I've been coding for 30 years now, so maybe it's down to experience, which is easy to accumulate with, given enough time. But I was just basically saying, here's a rule for up, down, left, right. So here's our rule for left, right, and here's our rule for up, down. And then, of course, I got the diagonal thing incorrect at the beginning. So, I don't know. There's probably even easier ways to do this. And actually, if row diff is 0, row diff signum is going to be 0. So actually, now that I think about it, we should be able to just pull out all of that. Does that give us, it gives us the same answer, right? So that's even cleaner. Yeah, and this is kind of a hack, right? Because I'm not checking this. I could put this in here, because we're inserting the tail every single time we make a move, even if we never move the tail. So we could put a check here to say, did we move the tail? And if we move the tail, then do the insert. Otherwise, ignore that. But it's so cheap and it runs so quickly. I'm not worried about it. In fact, what would this do in cargo run release? Just out of curiosity. With OBS and pretzel running and all that kind of stuff going on, how much faster is it in release mode? Wow, that's slow. Okay. This is why I don't build release. Yeah, so it took less than a millisecond to run both parts. So speed is not an issue. And Clippy, as long as Clippy's happy, we can commit these changes. Get diff. What we got? Yeah, so I changed part 1 to just run snake 2, run snake 10. I have a little run snake helper function. And then I ripped all this out and change it to the loop, and then I got rid of the prints. All right. (2022) day 9, part 2. Not too bad. Okay, actually, I want to take a look at the at my stats here, personal stats. Ooh, we cracked 25K. Nice.